motion. In other words, it has to move in the opposite direction to keep them from moving in the position you expect them to move in the first place. The repulsion should be pushing this apart. So the strong force field is keeping them together. So it's moving them the opposite directions. So that's called the strong force field. Okay? At the time of Albert Einstein, there were only two of this, but we'll get back to that. Okay, there were only two that were known in the modern science, except that the ancestors, I mean, the ancient Africans knew about the strong force field. Of course, for them to be able to make the pumping of the hydrogen units to make gold, they had to know about the strong force field, because you have to be able to overcome that. Okay, as you pump in more hydrogen units in here, okay, you know, the positive protons are going to repel the ones that are coming. As a matter of fact, that is the central problem for the cold fusion, which GAGUT has found a solution for. The world is looking for cold fusion. GAGUT has a solution to that.
Expand on cold fusion.
Well, you know, we'll get, yeah, well, if cold fusion is basically, the end result of cold fusion is like using a cup of water to run entire New York City. And it's recyclable. Yeah, just so that's how great it is. But GAGUT has a solution to that. Okay? So, which is why you need to support the Fire-Pit Institute technology, because unless we have funding, we can't put that into hardware. We have a solution to the cold fusion. Okay? So again, so that's strong force field. Okay? Another one, again, this, therefore, strong force field comes from the nucleus. And you can see how that produces motion. This produces motion, as you saw before. This is producing motion, and that we've proven how that produces motion by forcing the like charges to come together. Okay? Moving them in the opposite direction. Okay? Now, the fourth one is, you know, in the nucleus, a proton could undergo, okay? A proton could undergo a transformation, okay? When conditions arise, proton, which is a positive, changes to a neutron, okay? See, they're all there together. So neutron plus a beta radiation, okay? And a weird entity called antineutrino, okay? This is called antineutrino, okay? And this, of course, is beta radiation. Beta radiation. Okay? Beta radiation. Okay, and this here is called the antineutrino. Now, what happens is, proton is known to have approximately the same mass as the neutron. Okay? And a proton has the same charge, in a positive charge, which is already balanced by the beta radiation. Beta has a positive charge. Electron that has a positive charge, that's what the beta is. Okay? So the charges are balanced. You have a positive here and positive, they're balanced on the left-hand side. The mass from the left-hand side is also balanced by the mass on the left-hand side, you know, in terms of the neutron. Neutron balances the proton. So that leaves these two what they call massless. Okay? Massless. But massless simply means very small masses. Not totally zero. Zero means that it doesn't exist, okay? But it's massless in approximately, because in comparison with these others, it is practically zero, but it's not totally zero. It's very, very significant, okay? So what happens is then that for particularly, and of course, antineutrino has no charge, because there's no charge on it. So here you have a unit that has zero charge and zero mass. Okay? So, first of all, this combination is deadly. This is the basic origin of most of the cancers. where you have antineutrino and beta radiation. Okay? But what is more serious is the fact that antineutrino is not detectable by ordinary means. Simply because it has no mass and no charge. So how are you going to know its presence? So that creates a problem. But the fact that it's elusive, the fact that in reality nothing stops it, because if you have no mass you can pass through anything. And if you have no charge, the charge cannot deter you either. So it does not experience any or much resistance wherever it goes. Or, put another way, if it experiences resistance, the resistance is very weak. It can only experience a weak interaction or weak opposition on its track. Lead will normally provide protection with some of the radiations say this, like the kind that come out of the strong force field, okay? But lead cannot stop neutrino. Neutrino can pass through lead. Okay? And because lead and other materials only give neutrino a weak resistance, this force field here, because that's motion, neutrino is moving as a result of this here. Okay? So that motion it comes out of a force field called the weak force field. Weak force field. Simply because neutrino cannot be stopped, or you can only impede it in a weak manner. You can't really give it any strong opposition on this track, okay? So this therefore becomes the four force fields that are being studied in the modern day physics, if you will, okay? Now, but there's a common denominator as such, in the sense that all of them, produce what we said before, motion. Okay? The end result of this gravity, electromagnetic, strong, and the weak force, is motion. So, scientists thought that they all should have a common origin. And if we can find this common origin, it will give us an insight to the universe. So Albert Einstein spent his time, he was searching for what GAGUT solved, the solution to that problem, when he came out with E is equal to mc squared, which is something he's very well known for, okay? He wanted to unify gravity and electromagnetic force field on this base that they all produce motion, therefore they should have the same grandparents, okay? And so, but in the process, he was able to develop a very beautiful theory for gravity, as a force field, okay? And of course, Maxwell had already developed an electromagnetic theory that was quite beautiful. So he wanted to take what he developed for gravity and unify it with electromagnetic, so that he could say, okay, well, we have these two forces, and they come from the same origin, and from there go to understand the universe. Okay? Well, of course, from 1921, or actually 1916, to 1955, when he passed on, he spent his time, looking for ways to unify these two forces. With only a partial success, he didn't succeed in unifying them. So that left the problem, given his stature and so on and so forth, as a very popular, very important, very significant problem to tackle. Because it is believed that if you're able to solve that, then you've done something that Albert Einstein was unable to do. Okay? Okay, so that makes the problem very popular. So everybody jumped on the bandwagon trying to find it. Okay? And what GAGUT has done, okay, in terms of being a unified force field theory actually it's a theorem because we proved it mathematically. But also, in addition to explaining chemistry and its chemetic origins and so on and so forth, and the mystery itself that surrounds the name itself, GAGUT was able to unify all these four forces as well as all the forces that have not been known yet. Because the reality is that Albert Einstein, even if he had unified the gravity and electromagnetic, with the coming or the knowledge of strong and the weak, his accomplishment would have still been incomplete because people would have still been trying to find a way to unify strong and the weak along with those other three. So, but what GAGUT did was to unify all four plus others that have not been thought of yet. Now, how did GAGUT do that? Well, GAGUT examines, of course, it's a 35-year-old journey, okay, that took me from a city called Ida, that's Idaho without an O, okay, Ida, okay, in the Gawa Kingdom of Nigeria, okay, a kingdom that originated from Kemet, okay, as a result of the invasion of Kemet by the Arabs in 641 AD. 641 AD, the Africans in Kemet left, okay, and they were driven out of Egypt, if you will, okay, and those that came to Nigeria settled in a place now called the Gawa Kingdom. Okay? So 641 AD was when Africans moved from Kemet to what is today called Nigeria, the center part of Nigeria, and established a kingdom called the Gawa Kingdom. Okay? Now that's where I was born, in Ida, which is the headquarters of Ida, of the Gawa Kingdom.
And your ancestors told you that?
Oh yeah, no, that's part of the education that you learn in terms of, well, how did you get here? Of course, Oxford University studies have indicated that the Gala people, okay, and there are Galas all over the world, by the way. 75% of Ethiopian population call themselves Gala people. Angola is the land of the Gawas. Sierra Leone has, Gitchis or Gala people as well. Ghana, Nigeria, of course, we mentioned. The language in the Congo is called Lingala. Okay, Lingala is the main language in the Congo. That's the Gala. And so on and so. Even Madagascar has a significant population of people called Gala people. And I would be surprised if Australia has some as well. People we call Aborigines, could be part Gala people and so on and so forth. And of course, the South Carolina has the people you call the Galas and the Gitchis. The Gala people is the same people. So it's a name that people living in Egypt called themselves and settled all over the place. So that's the Gala Kingdom. And there's a very serious tie between the Gala Kingdom and Kemet in the present day setting, in the sense that embalming that Egypt has been known for is still practiced in the Gala Kingdom of Nigeria today, especially for the kings. The Ata, which is also a word for Ptah, okay, Ptah, okay, it's called Ata, or ATA, okay, in Nigeria is the title of the king. And Ptah is on the hill, the top of the hill, which Ata is like a father, which also the king, or which is the center, the hill of the people, and so on and so forth. So there's this tie, and so on and so forth. There's so much ties in fact, we understand that in some parts of Egypt, Gala language is still spoken. Okay? Yes. So that's a very strong tie there. But anyway, that's where I grew up learning all this stuff here. And of course, having known about the origin of chemistry, the mystery of the ancient Africans, as well as the fact that they developed